Pop quiz, you have a 0.25 molar solution of hydrochloric acid. What is the pH? Remember, for strong monoprotic acids, hydronium concentration equals the acid concentration. The pH equals negative log base 10 of hydronium concentration. 5 seconds. Go. Ready for the answer? The pH equals negative log base 10 of 0.25, which equals 0.60. The correct answer is 0.60, option B. In this video, you will encounter strong acids, a simple model to find pH, the ultra-dilute edge case where water autoionization matters, and a step-by-step recipe to check your work, so you can tackle any strong acid pH question. A strong acid dissociates essentially completely in water. Each acid molecule donates a proton to water to form a hydronium ion and the conjugate base. For strong monoprotic acids, such as hydrochloric acid and nitric acid, hydronium concentration equals the initial acid concentration. Here is the model. For a strong monoprotic acid, hydronium concentration equals the acid's molarity. Then pH equals negative log base 10 of hydronium concentration. This turns pH problems into quick calculator work. Example 1, a 0.040 molar solution of hydrobromic acid. Because it is a strong monoprotic acid, the hydronium ion concentration equals 0.040 molar. The pH equals negative log base 10 of 0.040, which is approximately 1.40. Be careful, this shortcut applies to strong acids only. Weak acids do not fully dissociate. For weak acids, you must use the acid dissociation constant, K sub A, and an initial change equilibrium, or ICE, table to solve, for hydronium concentration from the equilibrium, HA in equilibrium with H plus A minus. Mini checkpoint, you now have the core rules. Strong means complete dissociation. Hydronium concentration equals acid concentration, and pH equals negative log base 10 of hydronium concentration. Want to check your progress? Tap the link for a quick practice test and a concise study guide tailored to this lesson. Quiz yourself, skim the highlights, and jump back in. Let's jump into example number 2, 3.5 times 10 to the power of -4 molar solution of nitric acid. It is also strong and monoprotic, so hydronium concentration equals 3.5 times 10 to the -4th molar. The pH equals negative log base 10 of 3.5 times 10 to the -4th power, which is approximately 3.46. That works when the acid is dilute, but still stronger than water's own ionization. But what if the acid is so weak that water's ions start to make a difference? In that ultra-dilute limit, when the acid concentration is far below 1.0 times 10 to the power of -7 molar, the autoionization of water matters. Water self-ionizes according to H2O in equilibrium, with hydronium ion plus hydroxide ion, with the ion product constant of water, K sub W, equal to hydronium concentration times hydroxide concentration, which equals 1.0 times 10 to the -14th at 25 degrees Celsius. In the ultra-dilute regime, total hydrogen ion concentration, that is hydronium concentration, comes from both the acid and water. A convenient expression is hydrogen ion concentration equals open parenthesis C plus the square root of C squared plus 4K sub W close parenthesis divided by 2. For C equals 1.0 times 10 to the -8th molar, hydrogen ion concentration is approximately 1.05 times 10 to the -7th molar, giving a pH of approximately 6.98. For C equals 1.0 times 10 to the -10th molar, Hydrogen ion concentration is approximately 1.00 times 10 to the negative 7th molar, so the pH rounds to 7.00. A common error is thinking pH cannot be negative. It can. Very concentrated strong acids have hydronium concentration greater than 1 molar. For example, a 3.0 molar solution of hydrochloric acid has pH equal to negative log base 10 of 3.0, which is approximately negative 0.48. Here is your recipe. 1. Identify that the acid is strong and monoprotic. 2. Set hydronium concentration equal to the acid concentration. 3. Compute pH as negative log base 10 of hydronium concentration. 4. If the acid is ultra-dilute, much less than 1.0 times 10 to the power of negative 7 molar, include water's contribution using the combined formula. Quick recap. Strong means complete dissociation. Compute pH with negative log base 10 of hydronium concentration. For ultra-dilute acids, add water's effect via K sub W. Benchmarks: 0.25 molar hydrochloric acid gives pH about 0.60, 3.5 times 10 to the negative 4 molar nitric acid gives pH about 3.46, and 1.0 times 10 to the negative 10 molar hydrochloric acid gives pH near 7. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.